Hello everybody, welcome into another lesson. So today we are going to discuss right triangles and Pythagorean Theorem. So again, this is only in right triangles where you find this trick to work. So let's say you have the length of one leg. The two of the sides that form the right angle of the triangle are called the legs. The side directly across from the right angle, the slant, is called the hypotenuse. Well, the idea is if you take the length of one of the legs A, raise it to the second power, plus the length of another leg, call that length B, raise that to the second power, so far you have A squared plus B squared. You can set that equal to the length of the hypotenuse to the second power, which would be C squared. You can use this to solve for missing sides of a right triangle. So we will get started with our very first example here. Alright. So we have one leg being length 6, the other leg being length 8. We don't know the length of the hypotenuse, so we'll call that length C. That'll be length of C. We don't know what the hypotenuse is. The idea is I could call 6 my A. It don't matter if it's A or B. I'm just going to call 6A. I'm going to raise that A to the second power, so that's 6 squared, plus my B, which I'll make 8 the B. It'll be 8 squared because it's plus B squared. I'm going to set that equal to my hypotenuse squared, which is C squared. In the end, we're going to solve for C. But first, order of operations dictates I must do the exponents. So 6 squared is 36, plus the 8 squared, well, that's 64. That's going to still be equal to C squared on the right-hand side. So on the left, 36 plus 64, that's 100. You'll have 100 is equal to C squared. Since this is an equality, I could switch this around to be C squared, set that equal to 100. Okay, well that's good. I know C squared. I want to just find C. Well, what you got to do is take the square root of both sides. So C squared is equal to... Now, in a previous lesson when we did square roots of involving variables to the second power, we did both plus and minus the square root of the number. But it's impossible to have a negative length. You can only have a positive length. So we're only going to take the positive square root in this case of 100. You're not going to get a negative length. It just isn't going to happen. So C squared would equal, the square root of C squared is equal to the square root of 100. So on the left side, square root of C squared, you'll just get C. That'll be equal to the square root of 100. That'd be 10. So the answer is the hypotenuse C has a length of 10. That's exactly what you would get, a length of 10. And I got more examples here. Alright, what's next? Alright, we have a length of 10 on one leg, a length of 24 on another leg, which would be, we don't know the hypotenuse, so we'll call that length C. So one leg of this right triangle has a length of 10, the other leg has a length of 24, but we don't know the hypotenuse, we'll call that length C. Well, I'm going to make 10 my A, so I'll put in 10 and I'll raise that to the second power for A squared. Plus, I'll make 24 my B, so then we'll have 24 squared. So I got 10 squared plus 24 squared is equal to my hypotenuse squared, which would be C squared. So let's do the order of operations. Exponents, 10 squared, that's 100. Plus that 24 squared, which happens to be 576. We'll set that equal to c squared. So on the left side, 100 plus 576, that's 676. We'll set that equal to c squared. Since these are equal, switch it around. We'll make c squared equal to 676. Okay, well that's good. I know c squared, but I don't know just c. In order to get just c, I need to take the square root of c squared. So let's go ahead and we'll do that. We'll set the square root of c squared equal to this positive square root of 676. Because once again, we're not even considering the negative square root of this because you don't get negative lengths. It just doesn't happen. So on the left side, square root of c squared, that would be just c. That's going to be equal to the square root of 676, which is 26. So the answer is the hypotenuse c has a length of 26. That's exactly what you would get. C is equal to 26. I got one more example here of normal Pythagorean theorem. Then we're going to twist it a little bit. We're going to twist it around just a little bit after this last example. Alright, so let's see. We have a length of 30 for one leg, a length of 40 for another leg, but we don't have a clue what the hypotenuse c is. Well, we'll just do our Pythagorean theorem. We'll call 30 a. We'll make 30 a. So that'll be 30 squared plus I have my length, I have b, we'll call 40b, which would be 40 squared. We will set the 30 squared plus 40 squared equal to c squared, the hypotenuse. Alright, so let's do the exponents here. 30 squared, that's 900. So we'll have 900 plus 40 squared, that's 1600. And we're going to set that equal to c squared. Well, on the left side, 900 plus 1600, that's 2500. That'll equal c squared. Since these are equal, we could switch it around to make it where c squared equals 2500. Alright. Well, that's good. We know c squared, but we just want to know c. Well, again, we got to take the square root of these. So take the square root of c squared, set that equal to the square root of 2500. So on the left side, square root of c squared, that's just c. We'll set that equal to the square root of 2500, which is 50. So the answer is the hypotenuse c has a length of 50. That's exactly what you get. C would equal 50. Alright, let's twist this around just a little bit here for a couple of examples. I'm going to do two examples of switching this up. We're still using Pythagorean theorem, but it's going to be just a touch different. Okay? Let's see, I have the length of one leg being 30. I have length b for my other leg, but my hypotenuse is 50. So this time I know one leg and I know the hypotenuse, but I don't know the other leg that has a length b. Well, you're still going to go ahead and apply the Pythagorean theorem. So obviously 30 is our a. So we'll have 30 squared plus, we don't know b, so we'll have b squared. We will set that equal to our hypotenuse. C is 50. We'll set that equal to 50 squared. Okay, well, let's do our exponents. 30 squared, that's 900. We got that plus b squared is equal to that 50 squared, which is 2500. Alright, well, on the left side, use the commutative property of addition to switch the b squared and the 900 around. So we'll go ahead and do that here. Let me come over here. We'll have b squared plus 900 is equal to 2500. Okay, well, we got b squared plus 900. We want to just get b squared by itself. So in order to do that, we got to subtract 900 from both sides. So you'll have b squared plus 900 minus 900 is equal to what you do to one side, you got to do to the other. That'd be equal to 2500 minus 900. So on the left side, 900 minus 900, that's 0. You'll just get b squared. That'll be equal to 2500 minus 900, that's 1600. Alright, so now we got b squared. We just want to get b. Well, we got to take the square root of both sides. So take the square root of b squared, set that equal to the square root of 1600. Because what you do to one side, you got to do to the other. Well, on the left side, square root of b squared is just b. B is equal to the square root of 1600, which is 40. So the answer for the unknown leg b is equal to 40. That's exactly what you would get. And I got one more example here of twisting Pythagorean theorem around. Alright, what do we got here? Alright, we don't know the length of one leg, which is A. But we know the length of the B leg, which is 12. And the length of the hypotenuse is 19. So we know the length of one leg and the length of the hypotenuse. We don't know the length of another leg, though, which is A. Well, that's okay. We still use Pythagorean theorem. So you'll take your length a squared, so you just have a squared, plus the b would be 12, so we'll do 12 squared. We'll set that equal to our hypotenuse squared, which is 19, so that'll be equal to 19 squared. So we got a squared plus 12 squared equals 19 squared. Well, let's do our exponents first. We still have a squared plus 12 squared, that's plus 144. That's going to be equal to 19 squared, which is 361. Well, we got a squared plus 144. We just want to get a squared by itself. So we got to subtract 144 from both sides to get a squared by itself. So we'll do a squared plus 144 minus 144 is equal to 361 minus 144. So on the left side, 144 minus 144, that's 0. That'll just give you a squared. That'll be set equal to 361 minus 144. Let's see, 361 minus 144, that is 217. So we got a squared is equal to 217. Well, we know a squared, we just want to know a. Well, you got to take the square root of both sides in order to find a. So take the square root of a squared, set that equal to the square root of 217. So on the left side, square root of a squared, that just gives you a. That'll equal the square root of 217, which I know for a fact this is not a perfect square. So it's going to be approximately equal to sorry, I had to check something. Okay. Let's do the square root of 217 to 2 decimal places. That is approximately equal to 14.73. So you'll get A is approximately equal to 14.73. That'd be the length of leg A, approximately 14.73. So Pythagorean theorem again only works for right triangles. You take the length of one leg and set to the second power. We'll call the length of the one leg a squared, plus the length of another leg squared, which would be b squared. You set that equal to the hypotenuse squared, which is c squared. And you can either find the length of the hypotenuse, or you can do some solve it like you would normal variable equations and find the length of a leg. And then at the end, regardless, you just take your square root, and since we're doing a geometric length, you only consider the positive square root since you can't have a negative length, and you'll get your answer. So next lesson, we're going to talk about the distance formula, and we're going to figure out how far away coordinates are from each other on the coordinate plane. So I hope everyone has a good night. Take care.